Welcome to aminacademy.com. In numerical methods and analysis and interpolation with unequal intervals, let us discuss about Lagrange's interpolation formula for unequal intervals. Now we'll derive the formula. Let f of x0, f of x1, f of x2, f of x3 now like f of xn be the values of the function f of x corresponding to the arguments of x0, x1, x2, x3, xn like. Now this x0, x1, x these values may be is not necessarily equal to equal intervals, may be unequal. Now here let f of x be the polynomial. Let f of x be the polynomial nx of degree n. Now this can be represented by f of x. Then we can write f of x equal a, the arbitrary constant a0, x minus x1 into x minus x2 dot 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 into x minus xn plus next arbitrary constant a1 with x minus x0 into x minus x2 dot dot x minus xn plus then continuation of arbitrary constant a2, a3, a4 like. Finally plus an, that is x minus x0, x minus x1 dot 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 x minus x minus 1 now where a0, a1, a2, a3 are constants. Now we determine the n plus 1 constant, that is a0, a1, a2 up to an by using put x equal to x0. Suppose let it be this one equation 1 in 1 we get here f of, instead of x we are putting x0, that is a0, x0, x1 minus x1, x0 minus x2 like the factors x0 minus xn. That is, we can say from that we can get a0 value is f of x0 over x0 minus x1, x0 minus x2 of continuation x0 minus xn. Now let it be this is 2. Similarly, by putting x equal to x1, we get the second, like f of x1. Instead of x, you are putting x1. It gives a1 x1 minus x0 x1 minus x0 x1 minus x2, like factor of multiplication, and x1 minus xn. Similarly, from that you will find the a1 value. If f of x1 over x minus x0 x1 minus x0 x1 minus x1 minus x2, like continuing factor with x1 minus xn. Let it be this is 3. Now similarly we can get a2, we can get a2, a3, a4 values we can get. Now up to an, finally we can get it. An is f of xn over xn minus x0 xn minus x1 dot xn minus xn minus 1. Let it be 4. Now this all we have to substitute this 1, 2, 3, 4 in the original equation, that is substitute 2, 3, 4 in 1, we get f of x, because here we started with the function f of x equal to a0 x minus x1 x minus x2 dot 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 x minus xn plus a1, like factors up to an factors. All we have to substitute the value of a0 a1 a2 a3 up to an. We will get the final result of Lagrange's theorem, like here, which is final, is equal x minus x1 x minus x2 dot dot up to x minus xn over x0 minus x1 x0 minus x2 up to x0 minus xn into f of x0, then plus the second term is x minus x0 x minus x2. Here first is x0 missing, here x1 is missing, then up to x minus xn over x1 minus x0 x1 minus x2, then x1 minus xn, then f of x1 plus, like continuing the factors, the finally you can do plus x minus x0 x minus x1 and the factors continuation of multiplication of x minus xn minus 1 over x0 minus no xn here, because we started the xn minus x0 x1 minus x1 and xn minus xn minus 1 of f of xn. Here, suppose if you denote, if we denote f of x0, f of x1, f of x2 like simple values y0, y1, y2 like that, then the formula become like we can write this formula here. We can put instead of f of 0, f of 1, f of x1, f of x2 in terms of y0, y1, then finally we can get it f of f of x equal x minus x1, x minus x2, x minus xn over x0, x1, x0, x2 up. We can do like x0, xn, y0. You can write y0 plus next term is x minus x0, x minus x2 and x minus xn over x1 minus x0, x1 minus x2, like we can get it x1 minus xn, for this is y1, like it continues with finally plus x minus x0, x minus x1, x minus xn minus 1 over xn minus x0, xn minus x1, continuing with what xn minus xn minus 1, here yn. This is a Lagrange's interpolation formula, this one. We have done. Please subscribe our YouTube channel.